Hello further math students, and welcome to this video on the inverse matrix, which is the start of chapter 12. In chapter 11 we looked at a few different types of matrix arithmetic. We talked about matrix addition, subtraction and multiplication. Using or finding an inverse matrix is sort of a bit like doing matrix division. It's quite a complex process and there's a fair bit to understand, so let's get stuck into it. The first thing that you need to know about is this thing called the identity matrix, which you might remember from the last section. And the identity matrix is a square matrix with ones on the leading diagonal. So from top left to bottom right, every number is a one, and zeros elsewhere. All right, so these are three examples of an identity matrix, but the identity matrix can be bigger and bigger and bigger as long as it's square with ones from top left to bottom right and zeros everywhere else. The identity matrix has the property that if you were to take any matrix A and multiply by the identity matrix, you would just get the same matrix again, right? So there's a worked example here on our notes where we take a matrix A and it's just got elements 1, 2, 3, 4. It's a 2 by 2 matrix. You can see here that if we took matrix A and what we call post multiply, so multiplied by the inverse matrix after A, you could go through and do your run and dive, across the rows, down the columns, across the rows, down the columns. You're just going to end up with the same matrix again when you multiply by the identity matrix. And even if you do that multiplication the other way around, because we know that the order of multiplication can sometimes change our answer, but with the identity matrix, even if you do it the other way around, so I times A, again, going across the rows, down the columns, adding them all together, doing your thing, you're still going to end up with the same matrix A again. So the identity matrix is kind of like the matrix equivalent of the number 1, where if you times by the number 1 or you times by the identity matrix, you just get the same thing that you started with. Okay, the inverse matrix, which we call, if our original matrix was A, we would call the inverse matrix A to the power of -1. That's how we write it. The inverse of a matrix has the property that if you multiply a matrix by its own inverse, so A times A to the power of -1 or A times A inverse, whichever way around you do it, so if you did A inverse times A, you would get the identity matrix. All right, so in other words, if you multiply a matrix by its own inverse, it will equal the identity matrix. That's the definition of the inverse matrix. And it's important to understand that only square matrices can have an inverse, so any matrix that's not square will not have an inverse. But there are some square matrices that will not have inverses. So not all square matrices have inverses. All right, here's an example here. We've called it example 2, but really it's the first example, so sorry about that. We've got matrix A and its inverse are shown below, and we're being asked to show or demonstrate that if we multiply the matrix by its inverse, whichever way around we do it, we're just going to get the identity matrix. So this is just a way of almost like proving that these two things are the inverse of each other. So let's do A times A inverse first, which would be the matrix 2, 3, 3, 5 times 5, -3, -3, 2. I'm writing pretty small here because matrix multiplication will take up a fair bit of space. So this is just a good recap of going, across the rows and down the columns. So for our first element, first row, first column, we're going to do across the first row, then down the first column. So 2 times 5, which is going to give me 10, plus 3 times -3, so that actually gives me plus -9. Then if I go across to staying in the first row but the second column, I'm going 2 times -3, plus 3 times 2, and then going down to the second row, so second row, first column, 3 times 5, plus 5 times -3, so that gives me plus -15. 3 times -3 gives me -9, plus 5 times 2, which gives me 10. And you can see what's happening here. We're going to end up with the identity matrix. 10 take away 9 is 1, -6 plus 6 is 0, 15 take 15 is 0, and -9 plus 10 is 1. So we've shown that A times A inverse gives us the identity matrix. Let's do it the other way around. All right, remember in the show that question, you already know the answer. Your, job is to demonstrate how to get to that answer. So if we did that multiplication the other way around, and it's a little bit tedious, I know. So if you want to fast forward this to the end of the example, then go for it. Right, but we're going to show, using our matrix multiplication, that we should get the identity matrix again, even if we do this multiplication the other way around. So crossing down, 5 times 2 plus negative 3 times 3, so actually that gives us a takeaway 9. If I go to the second column, so first row, second column, 5 times 3 is 15, plus negative 15. Negative 3 times 2 gives me negative 6. 2 times 3 gives me 6. Negative 3 times 3 gives me a negative 9 there, plus 2 times 5, so plus 10. And what do you know, we're getting 1, 0, 0, 1 again, which is the identity matrix. So we've demonstrated that both of these multiplications are equal to, well, they're equal to each other, so I can say that is true, but they both equal the identity matrix, which is what we were required to show. Okay. Moving on to the next key idea, which is the determinant of a matrix, right? So we are working towards the inverse, but there's a few things we have to understand before we get there. The determinant of a matrix helps us to find the inverse, and it's part of the process of finding the inverse of a matrix, but the determinant of a matrix actually tells us some important information as well. So it's really useful that we're able to calculate this before we calculate an inverse. The determinant of a matrix will be a number, and it can be positive, negative, or 0. Now, in the further maths course, you only ever have to manually, so without a calculator, determine the inverse of a 2 by 2 matrix. So if it's 3 by 3 or bigger, you'll always be able to use your calculator, but there will be some questions where you'll need to know how to find the inverse of a 2 by 2 matrix by hand. And the rule is that if our original matrix A was had the elements A, B, C, D, then the determinant of matrix A, which can be written a couple of different ways here, sometimes with these vertical lines or sometimes with det A, is calculated by, and it's really like this, you take the leading diagonals, the A and the D, and you multiply them together, right? And then you subtract the other two diagonals as a product as well. So it's A times D minus B times C. On your calculator, and you can see a screenshot there, you can also do this, and again, this is handy for the bigger matrices, by going action, matrix, calculation, and then DET. Right, and you can see an example of how that's typed in there to give you the determinant. So, in example 3, which is really example 2, we're going to find the determinants by hand and just get used to this sort of multiplication. So with the first one, you've got 2 times 5, so we could say det A equals 2 times 5 minus, and then it's the product of the other diagonals, so minus 3 times 3. Now you don't have to write brackets here because multiplication gets done before subtraction, but some people like to put brackets just to kind of really emphasize that you're doing the product first and then you're subtracting. So it's 10 take 9, which of course is equal to 1. All right, so the determinant of A is equal to 1. The determinant of B, same thing, so 2 by 3, 2 times 3 I should say, minus 2 times 3 again, with or without the brackets. All right, so that'll give me 6, take away 6, which is actually 0, so the determinant of B is 0. And the determinant of C, yeah, you get the hang of it, right? 2 times 3, take away 2 times 4, which is 6, take away 8, which is negative 2. All right, the question did also tell us to do it on the calculator as well, so just to run through that really quickly. So hopefully you can see my calculator there nice and clearly. So it's action, matrix, calculation, and then DET. All right, so thankfully they're all pretty straightforward to follow, and then we just need to remember how to input a matrix. So keyboard math 2, it's a 2 by 2 matrix that we're putting in for these questions. So the first one we had 2, 3, 3, 5, and you'll see the calculator is just going to churn out the determinant straight away. I'm just going to get lazy and copy that down to check our answer for B. Yep, we were right. And lastly, to check the answer for the determinant of C. And there we go. So nice and quick when you can use the calculator. All right.